today, after this lecture, we're going to work on getting the wings de-skinned so we have that skin to start practicing rivet layout and riveting on. But, so some of you will be working on the wings. Some of you will be finishing up getting signed off drilling out rivets, which that's the plan. I planned today for that. But some of you might today be able to start shaping your pieces, which we'll talk about that, and start layout today. Maybe. Some of you. A couple of you. So if you don't get this done today, don't worry. It's not planned for everybody to start this today. I think I said this at the beginning of the class. I'm expecting people to be kind of at different places, kind of getting spread out. So you all have different skills in different areas. So I'm putting this lecture today, so those of you that do get to lay out aren't held back because we didn't talk about it yet. Those of you that might do it tomorrow or the next day, just take good notes, look back at the PowerPoint, and we'll review this tomorrow and the next day. So we'll review, reinforce, always feel free to ask questions. So we are going to talk about how do you select rivets. We have bins of rivets out there. How in the world do you decide which ones you want? What are spacing requirements? What are those requirements based on? What kind of spacing should you do? And what methods are easiest to meet those spacing requirements? So when you lay out a repair, what's the easiest, hopefully, least amount of pain? I won't say pain-free way possible. So you should understand by the end of this lecture, or begin to have an understanding of, how to plan and perform rivet layout to airworthy standards, because that's what we are aiming for. We're actually aiming beyond airworthy, but we'll start you off there and then push for improvement. Resources. Obviously your airframe book, AC 4313, and we're going to refer some to your general textbook, kind of like yesterday, that has some information, kind of what is a rivet made of, stuff you learned in Maths and Pros, that if you forget it, it's useful to refer back to that. So to properly plan a rivet layout, you do need to know the rivet size and the rivet type. We're going to review rivet identification numbers. You have to know the appropriate length for a properly formed shop head. So the shop head is not the nice manufactured head that you were drilling out. It's the other side that gets bucked by the bucking bar. And the appropriate diameter of the rivet to carry the strength of the material. So that's kind of what a lot of this is based on, is how large of a diameter do we need to get the correct strength. Alright, here's your second quiz of the day. You're not graded on it. Looking at these two pictures, now we haven't talked about layout or what's required at all yet, but just using your skills of detection and deduction, in these pictures do you see anything that you'd be like, I don't think that's airworthy?
That one on the left-hand side, there's one that's super close to the edge.
I agree. I agree. Tiki, you think you were next?
There's something that the piece broke off on one on the left, and the other one is not
how was you with this one?
Anxious.
Yeah, more about the specific, really the rivet, yeah.
That last one, the end is really flat.
Yeah,
Way too much.
super squished. Looks like the elephant sat on a pancake.
The second one from the right's not even buffed.
Yeah.
That was like not even
That one they didn't even get the bugging part out, maybe for a quarter of a second. But yeah, it is not squished at all. And this one, really squished. So, before we even talked about rivets and what to look for, you're already picking things up. So, excellent. Now let's review. So, I stole this slide from Brian's PowerPoint. You have seen this before. If you look at this, you're like, oh, I forget what that is. Since this is a review time, you are very welcome to go to AC 4313 and use that as a reference to decipher what the code is. But anyone, we'll start at the bottom. Remember what this refers to and what it means. Yes. I'm in a universe. You're in a universe. What does that mean? Oh, round. The shank is round. Ah, thank you. Yeah, so that refers to head type. And anybody find where this is at in AC 4313?
Page 4-22.
Woohoo! Thank you. So go ahead and turn there because I'll be asking more questions. On page 4-21, there's a little chart that gives you kind of a brief overview, but then 4-22 and 23 has lots of information. Nice, lovely charts. And page 4-24 at the top gives an example of identification marking of a rivet. So you can refer to those. So we go. Anybody remember what the MS stands for?
Military standard.
Military standard. So military standard 20 and 426 is the head style. What does the next portion, DD, and what does that specifically mean? Material. And what, how will that be indicated on the head?
Two raised dots.
2 raised dots. We'll talk more about that. But very good. The alloy of the rivet. And what does this next number indicate? Yeah. Excellent. Beautiful. Get this started. Yeah.
So the MS-20 426, that's effectively the same thing as AN 426.
Correct. Yep. You'll see military standard, or I'll go ahead and ask now. Anybody remember what AN, what that stands for? Army, Navy. Yep.
But as far as the type of rivet,
Correct.
like if it was MS-20 470, then it's the same as AN.
Correct. Yep. Very true.
And I misspoke. That's not a round head, that's not a universal, that's got some.
Well, rounded
Ah.
head is an MS 2047, but it is also a universal head according to our wonderful.
We're going to come back to that in a minute.
Wonderful.
So, this last number after the dash, a dash 6, what does that number indicate? Length. And what increments is length? 16. So now, looking at this lovely chart, we had the 426 down here. Now we have a 470. What is the difference between those rivets? And you had it up front, but I don't think everybody heard it.
Type of head.
And what type of head 426. Countersunk, flush, flat, interchangeable. Mostly you'll hear it as a flush head rivet. And what is a 470? Universal. So be careful, round heads are different than universal head, and you can see that. So we have brazier heads, which are more, a little different, but you can see on page 4-22, there is a round head, and it is very round. Not common. And then there is a flat head that is different from a flush or countersunk head. And then down a little bit the brazier, which is more of a half of an oval rather than a half circle. And then the universal head, which is rounded but flat on top. So we got that head style, and do you remember? So here's a little tidbit. So here is AD. If there is an absence of letters, do you remember what that means? Not.
Like a hole in the head or something? No, we're talking about rivets, not holes.
Right.
Yeah, I'm thinking the wrong thing.
It's not made out of any material.
So, no letters mean it's a mild steel rivet. Pleasure tidbit. What if that is an A instead of AB? Look in your. It will be a plain head, and it will be soft aluminum. So, I'm going to talk a little more later about this. But an AD, that's what's most commonly used. But in your riveting project, when I give you your whole project, actually later today, there is one row of rivets, and this is going to be next week, definitely, maybe after Christmas, where you're going to have to do most of your riveting project is going to be AD rivets. But there's one row that is just A, soft aluminum. People, by that point, it's like step, 7 or 8 in the project, they're just blazing through. You got a pile of AD rivets, rivet them in, bring them to me. How's this look? Beautiful job. Wrong rivet. So, and we'll talk about that when we go over the project. But just, I'll remind you several times, so hopefully it gets settled in your brains. It won't be an editing error. It's actually an A rivet, not AD.
And adding here.
Editing. So specifically, there we go. What size rivet is this? I didn't hear. I heard noise. Say it again. 4/32, and what dimension is that? Good, 1/8, and as far as the rivet is a diameter. Very good. That's a 1/8 diameter rivet, and what is our length?
460.
Yep, 4/16 converts to 1/4. Oh, it's 1/16 increments. Yeah, I was looking at, wait, what? All right. Yes.
How do you go from, on the next slide, but rivet size to drill bit size?
We will talk about that tomorrow when we talk about installing it. Okay, now we'll go, I'll show you the slides. I was kind of jumping ahead talking about specifics of rivets. Here is that information. So, also, backtrack a second. If you want to kind of just note those pages in AC 4313 that talk about rivet head styles, countersunk, round, brazier, flat, universal, just know where that is. You don't have to memorize this stuff. Goodness gracious, that'd be a pain. but know where it is so you can come look it up, find the information if you're asked the information in a testing situation. Now, prepware will pick out and written tests will pick out some random specific ones to ask questions about. We'll go over that stuff, but just know where to find it for now. So, AD or 2117 alloy rivets are the most common, and you do need to know that. To know that AD rivets are the most common because they're very high strength, they have good shock resistance, they are a structural rivet, they do the job, they do it very well. This is an alloy of copper and magnesium, with copper and magnesium, and most common is a universal head, so it's kind of round but flat on the very top, and it will have one dimple in the center. So that's mostly what you were drilling out yesterday. Then we have countersunk rivets. So these, the metal is prepared, and you saw some of that yesterday too. Some of it you saw was dimpled, some of it was kind of ringed out. So you have to prepare the metal so this sits down so the top is flush with the surface of the metal. We have a whole fun lecture later on that. But they provide smooth airflow for aerodynamically critical areas, so like the forward top portion of wings. Now, the downside of this is the metal is altered, either a countersinking tool or dimpled, so that metal is changed, so it is a little bit weaker. So if you don't need to countersink, it's best not to. These are stronger. But the spacing requirements are going to be a little bit different for countersunk because you alter the metal. And hopefully some of this is a review from Ryan. Come back. Icebox rivets, and they are identified by D and DB, so 2017, 2024. If you need help remembering those designations for icebox, you can think of me outside in the cold going So these are used for, they're much stronger. They're very hard and susceptible to cracking, so they have to be heat treated to soften them when they're driven so they don't split when they're driven. So the manufacturer heat treats them specially and then immediately freezes them. Or if you have the ability to heat treat these rivets, as soon as you heat treat them, they must be immediately driven in their softened state before they harden up so that they're not destroyed. And on the box that you receive that's in dry ice or kept in your freezer, you must install them after you take them out of the freezer within a certain amount of time, and it will tell you that depending on the rivet. If you don't install them in that time frame, like an hour or 2 hours, whatever it is, after taking them out of the freezer, then you have to send them back to the manufacturer for them to reheat treat if you're not able to heat treat them. So really pay attention if you're ever working with icebox rivets. Just take a couple out of the freezer at a time that you can safely drive in the time requirement. Also, these are used not very commonly on registered aircraft, but they're becoming very popular on experimental aircraft. And, well, actually some large, like Boeing and big stuff, they'll use them because they are so much stronger. But they're used in the manufacture of the aircraft, and full shear strength is you can do a repair with an icebox rivet, go out and flat. You have to wait till that rivet hardens back to its hard state before that's considered structurally sound. Now, usually it's used in building the aircraft, so it could be weeks before you fly.
I was wondering, when you receive those from the manufacturer, do you have to either, do they come heat treated, or do you have to heat treat them then freeze them?
They come heat treated and in a frozen container,
Okay.
like usually packed in dry ice or something.
But if they're left to thaw, you have to reheat treat them?
Correct.
Okay.
Correct. And it may have instructions how to do that. If you don't have the equipment, the correct way to do it, or you don't have experience, then if it does thaw and it goes over the amount of time, then you have to send them back to the manufacturer. Or reheat treat them if you have the ability to do it yourself. The two different ones, the D, pretty easy to remember, is indicated with one raised dot, and if it is DD, it is two raised dashes. So DD, D, not Morse code, but it could be. Also, the reason that they like them for experimental aircraft is, so a lot of these guys have money they don't know what to do with, because these are expensive. But because they're heat treated, frozen, so it keeps them in that state of softened, they are softer, so they're a lot easier to drive than AD rivets. So experimental guys like them for that.
With the two raised dashes, is that gonna weigh up riveting them?
No, they're not that. I mean, this is like an extreme picture
Oh, okay.
of it. Other questions on it? Here is the aluminum, soft aluminum rivets. They are soft and easy to drive because it's soft aluminum, but they're for non-structural use. So things like fairings or baffles, attaching plastic parts, because they're soft, they're not going to have the strength that a structural element would require. And the part number would look something like this, 470, just an A. No D beside it, just the A. And it's a plain head, so it has no dimples, no dashes, no dots, no nothing, just a plain head. So, I would advise you just be a little cautious, I don't know, observant, with your bins of rivets. So Anna, I believe she went through most of the bins to make sure you have all AD rivets in your bins. A couple years ago, we're not sure, we think the end of the year somebody sprinkled in A rivets. Yeah,
On purpose.
they would have been 21. No, you don't know who did it.
Yeah.
So just when you grab a handful of rivets, just double check them that they are AD, and then when you get to the A's, double check that they are A's, because, yeah, that. And you find fingerprints, that's. Okay, we're going to pause there before we talk about more rivets and take a break, come back at 35. And if people that are interested in helping with the Christmas program want to come up here for 2 minutes. That's awesome. So, have you led congregation?
I sing.
You sing? I know
That's
you
all I
sing.
do. That's all I do. I just
He
sing.
sings, bro.
You sing too.
I'm telling you, he
Kurt, I know you sing. You better get up there.
I sing. I make a joyful noise. I like you to say it.
Praise to the Lord, bro.
Isaiah?
What? What?
You gotta sing, bro. I wanna hear that beautiful voice of yours.
No. I have experience.
No.
Having those singing this time, I've never organized 4 parts.
No. It's
You know,
just
you guys sing
simply.
high, you guys sing low, you're somewhere in the middle.
I don't think they do.
What is
Every
I'll
part
chime in,
harmony.
Bass clarinet.
Piano.
Only through voice, by the way.
Okay,
Got a lot of instruments.
piano. So,
We'll look at piano.
so Nick's,
Yeah, that's, I'd rather not.
so Nick's wife has a really nice keyboard. Hannah has a nice keyboard, which is right now in my apartment. So I can either ask her, I can bring hers, or Nick's wife. If you'd be willing to play piano along with these.
Oh, yeah.
Perfect, because that'll help, that always helps a ton.
Do you have music for these?
I believe so, yes.
Okay, 'cause if you
I'll
don't,
look
So,
I know
I'll
I've
look
got
through
some.
and find,
I will,
ooh, hey, look, sheet music.
I have music.
Yeah, but it's probably not in our key.
Exactly. So that's the problem. So I play the last couple years I played violin, and so then I chose music that was for the violin that worked for me. I do not know how to play that. If we have a piano, that'll keep us on track.
I'll see what I can
I know I've got most of that music.
take, let me take a picture of that.
Yeah, because our instruments are in B flat.
Yeah.
We'll be
Yeah. So
Which I've worked on transposing a little bit, so worst comes to worst, I look at that and then just make my own,
yes,
make my own version.
yes. Do we want
With a track.
a practice session or just send it on then?
Full send, absolutely full send.
What do?
I prefer something.
next week?
I think it'll be next Tuesday. Or maybe Wednesday.
When is this?
Yep, for Devo's time.
Devos.
Oh.
Just for it's like
Oh.
20 minutes during Devo's. Super flat. Like just have fun. Like it's not
You should bring in a cajon.
not a performance, just a time for everybody to hear.
Bring in a cajon. Cajons are great for this kind of stuff. Do it. What is that?
I think it'll
A
be great
cajon?
if it's just
It's
Devos.
this little like
It's like a
box
box
drum,
drum.
and then
Oh,
you
yes.
just sit on it.
Oh yeah. Yes.
It's great. It's perfect for stuff like this.
Guitar, box drum.
Grant, I think we just have a beatbox.
The single woodwind out of a power jack thing.
Yeah, that's what we need. That's what we need. For guys, let me lead with my beatbox.
Did you bring it in there, buddy? You don't even need that,
And
like a
your
tuba or
instrument.
something?
Got a trumpet.
No.
Okay, that's fair.
So do we want if
It's an
we
even match.
I'm gonna double check with Nick, but I think Tuesday's the slot is not filled yet for Devo's. So we'll do it Tuesday. Should we would it work Monday afternoon to just kind of coordinate what's going on? Are you good? To my piano player and suddenly I don't and just like don't do anything.
No, that's great. If you want to, I mean, if you've experienced with the keys, if you want to choose out keys and or whatever, and
I can
even
pick all these out.
spontaneously, like I don't need an order. You can
Well, I
just
have
go on the
You don't,
fly.
I've never.
So I have an order because I had like scripture to read and I'll
Sweet.
somebody for that.
Could be a
I'll let
great
you like
breakthrough.
know.
Yeah.
Sure.
Bro,
I'll
can't
I'll
hear
only
you.
use whatever you.
You've already, oh, you're right. You already know what type of music I
And if you want
Christmas music, I don't allow. You could like, I could put on.
You can make it the same style.
are you because I think Andy has music
I
from
could
this
put
one
on some
last year.
gnarly
Like if you want actual
like
music
some gnarly
that she can
house
use.
shit.
I can ask her for that.
Getting that Christmas vibe. Yeah.
Or if I want to look at what I have.
What might be
Depends.
back roads or main roads for everyone to see together is, I guess you need both. I can make a slideshow that has like lyrics for each.
We have it. Yeah, we had a slideshow, we had the lyrics.
We're not singing.
No.
Jen and I, it's kind of hard to sing when you've got an instrument in your mouth.
Yeah. So it's basically, and I'll give you, actually,
Just stick them right up your nose.
so, but then I'll show you, yeah, I'll show you the slideshow. That's on my speed. Which you can look at. And
I would have done faster. Yeah.
I'll help you run the slideshow.
So you're the issue.
Maybe with you and I'll pass someone over.
Praise team? Okay. those are like hymns, so it's repeat.
That'll be fun.
Thank
Thank you
you.
for organizing that. That'll
Thank
be
you
awesome.
for your willingness.
Are you gonna be playing violin?
We'll see, I'll bring it on Monday, and
Okay.
we'll see what keys work.
Okay.
Cause I play off of all this, so it's easier for you guys to play it in a different key that I don't like.
Sure.
We don't need a violin on every song.
Sure. Yeah. It's
You want to give us a?
I'll use it for my violin music, but if you wanna look
I just
through
need
it,
the list of songs.
yes,
And
we can keep that.
I'll pick keys and send them to the. That way by Monday everyone is.
Yeah.
alright. Christina, do you wanna throw
Oh,
your
yeah.
number in there too?
super susceptible because where is it at on our galvanic chart? And steel rivets for corrosion resistant steel, where you'll see that is firewalls and exhaust stack brackets.
What does mild mean? Like mild steel.
Mild steel. Oh. Ah, ooh. Where could you go to find that information? No. Actually, your general textbook in page 7-54, 7, and 7-12 review all of that. Like, what is mild steel? What is corrosion resistant steel? What is 5056? What is well, all that stuff will be in your general textbook from math and roads. Okay, questions on those types of rivets? Yes.
So the copper rivets on a steel bar are not what we want? Or is that?
Correct.
Is it
Yep.
correct? Okay.
Yep, I just found pictures of using the wrong alloy with, yep, causing corrosion. So now we're going to talk, as it relates to rivet identification and selection, rivet strength and stresses. So, do you remember what is the most common stress our rivets are subjected to and that we want them to fail under? Yes! Shear stress. Woohoo! So, the riveted joint should fail by the rivets shearing rather than metal tearing. Metal tearing makes you tear up. The tear causes a tear. The shear strength of the rivet, therefore, needs to be slightly less than the bearing strength of the material. And shear loads cause the most rivet failures because that's how they're designed. You want them to shear before they fail under bearing. And here's the really nice part. The next things we're going to talk about a little bit later on how to calculate how far you place rivets from each other, how far you place them from the edge. That is all based on keeping the shear strength slightly less than the bearing strength. Engineers figured that out for you. So they gave you the data. You have to know the data, which we'll talk about, but you don't have to do all the strength tests, which is really nice. And here is what can happen if we shear the metal, or the metal bearing is, torn, but we want the rivet to shear. Anyone remember what, I just mentioned it the other day? Difference is if we have just two pieces of metal where the rivet could shear at one place versus three pieces of metal and it may shear at two places. So that's if it's under single shear or double shear load. And if it tears and if it could shear at one place, single shear. If it could shear at two places, double shear. So just be aware of that. And then here is a reminder of the bearing is actually ripping the sheet metal up and out. You'll see the heads of the rivets kind of like displaced, tipped off to the side like these guys. Not a good thing, not what you want to see. When it comes to a rivet failing, or if you're drilling, you mess up your own rivet, you will replace rivets with those of the same size and same strength as the original whenever possible. There's other things we'll talk about if you mess it up really bad. But I want everyone to go to AC 4313, page 4-24, paragraph 4. consider that when you're laying out your spaces. Rivets may not be replaced by a type having lower strength properties. That makes sense. Unless the lower strength is adequately compensated by an increase in size or greater number of rivets. So if you find that, oh no, you ran out of your rivets you were using, the only ones you have left are lower strength, you can either do more rivets per inch to get the same strength back, or size up to a larger rivet. And then it gives you some examples. You can replace a 2017 rivet of 3/16 diameter or less and 2024 rivets of 5/32 diameter or less with 2117 for general repairs, provided the replacement rivets are 1/32 inch greater in diameter than the rivets they replaced. I read through that because it is just one example, but you are going to see that in prepware. They're going to ask you those specific rivets. Now, this is generally speaking. If you're working on an aircraft, where are you going to go for specific information? The maintenance manual. And that would tell you what is allowed for that area of the aircraft. Yeah.
How strict is the, like, if you make the hole on the rivet when you're removing it, how strict is the drill out and go to the next step up?
We'll talk about that. So it kind of depends how, can you drive another rivet and does it fit snug and get the dimensions you're supposed to, or is it loose? Yep. Yeah.
When you are laying out your rivet pattern, are you keeping in mind that, like, in the future, someone might have to size up their rivets?
Yep. Yeah.
So you're gonna give things a little extra space.
Exactly. Yeah. And you hope to people before you did that, but doesn't always happen. So, yes, you need the same strength rivets, or if they're not as strong, a larger size or more rivets. These are just some pictures. You don't have to memorize this at all, but just some visualization of different ways that a rivet can fail, or the sheet metal around the rivet. Any questions on that? I was going to quiz you on the material the rivet is made of, but you don't need to really know that. Okay. So here is how to measure a rivet, if you have forgotten, from Ryan's class. Remember, very important to remember, that when you measure the length of the rivet for a universal or a round head rivet, you go from where that head stops and where the shank starts to the tip. If it is a flush countersunk head, then since this part is down in the metal, flush with the metal, you have to measure from the top of the head the whole thing. So just remember that when you are determining rivet length. And what kind of tool do you think you could use to do that?
Just this.
Just a ruler. You could use your machinist scale. Caliper will be more accurate. So you just take this guy and you can use this side to tuck under the head, go down to here, and this one is super easy to just ka-chunk, grab that whole rivet. So keep your calipers handy because you'll be measuring rivets, double checking your drill bit. And what is the length? Measure it in what increment? 1/16 of an inch. Drill that into a head if you haven't yet. So how do you determine what length you need? This is the mostly magic formula. Bottom. together. So when you are out in the lab doing a riveting project, you'll figure out how thick that is. But it's going to be super easy because in your lab it's going to tell you take a 32 thousandths piece of material and attach it to a 20 thousandths piece of material, and then boom, you just add those two together. That's your grip. So that gives us this distance. Obviously our rivet has to be at least that long, but we need enough extending out to form a proper shop head. So we need enough extending that when we put the bucking bar to it and wrap it down, that just mushrooms to a beautiful shop head. And to get that, generally speaking, it's going to be 1.5 times the diameter of the rivet. So you have to know your rivet diameter, multiply that by 1.5, take that and add it to your grip, and that will give you a nice length rivet that will give you a good shop head. So yes, grip is total combined thickness of materials to be joined, 1.5 times diameter, gives the amount of shank needed to form a proper shop head. Questions on that? So, how do we find the diameter? So glad you asked. Diameter, magic formula, 3 times the thickness of the thickest sheet. Now, when you have a rivet, or you measure your thickest sheet, multiply that by 3, you're going to get oftentimes kind of a number that's in between rivet sizes. If it is in between rivet sizes, always round up. So go to, if it's between a 3/32 and a 4/32 rivet, you go up to 4/32. So that's kind of how engineers have designed when they're thinking about the strength needed. They're assuming that you're going to round up for diameter. And yes, question.
So this diameter, is that of the rivet, or are we just measuring the thickness and then?
So diameter equals, you measure the thickness of the thickest sheet. Multiply that times 3, and that is the diameter of the rivet that you'll select.
Oh, so that is the diameter of
Correct. Yep. Yes.
You had mentioned sizing up the rivet, so I'm assuming this is the minimum diameter it has to be, not, it has to be that diameter?
You want it to be as close to this as possible. Because if you go too big, what will happen?
The shear load will change.
Right. And what kind of stress is going to destroy your work?
Bearing,
Yes.
but then why is sizing up okay?
Because that's what engineers design everything for. So when they tell you use 5 rivets per inch, there is a little bit of wiggle room on either side of that. And it's better to size up because you're still within that wiggle room than to make it too weak and now your whole thing isn't structurally strong enough. Yeah.
I feel like this should change depending on what material you're joining together.
I mean,
Some
like
material will,
alloy or thickness?
alloy. We factored in the thickness, but the materials will be different.
So that's when, if it's something other than aluminum, so these are, pretty much all this is for aluminum. And when you get other things, you'll go to the manual. And the manual will probably tell you the exact rivet to use, like use a 4-5 or something. So these are generalizations taken from AC 4313 that if you're thrown out and like, oh man, I don't have a manual for this, and the manual doesn't have information, this is what you follow. Or if they throw a project for you to do during practical, which typically they will give you a manual to follow. But these are generalizations that balance, they have enough rivets for strength, but not too many holes. All of that, the engineers have calculated for you. Also, with rivet diameter, this kind of goes into our next chart, so I'll just talk about it for a minute. With rivet diameter, if you get too large of a rivet diameter and too thin of material, when you try to drive that rivet with your rivet gun and bucking bar, that's going to damage the metal because of the force of the gun. You're going to damage your thin metal. But if your diameter rivet is too tiny and too small, obviously it's not going to have the strength of that riveted joint. So that's some other things they are pulling together. This is a lovely chart from AC 4313, page 4-41. And there's more charts, but this is just the one example I pulled out. And this is for a specific material with specific rivets. So this chart does not apply to everything. It's just one example. You can always go to your maintenance manual, but this is one example if you don't have a manual to follow. And if you go to that chart in AC 4313, you'll see over here is listed metal thickness, and then here is listed the rivet size. So the notes, whenever you use a chart like this, make sure you read through all the notes to know what applies, what could be different. So if it's a stringer, an upper surface of the wing, you can use 80% of the rivets shown. So what this is showing you for 32 thousandths material, you want to use, if you're using a 3/32 rivet, you gotta get 11.1. This is engineering. Rivets in protruding head rivets required per inch. That is a whole lot of rivets. You have to have many rows to get that in 1 inch. So we might move over. If we use 1/8 inch rivet, we can go down to 6.2 per inch. But there is a note under note, letter C, for a single lap sheet joint. So that's what you're going to be doing. That's your project where you're just overlapping one single overlap. 75% of the number may be used. So you can take 6.2, 75% of that. It's a much more reasonable number to fit in 1 inch. But you have to read the notes to know that. And it tells you in the engineering notes what they use to calculate this. Letter C under engineering notes is also important. Combinations of sheet thickness and rivet size above the underlying numbers are critical or will fail by bearing. Those below are critical in shearing. So the way this works, if we stick with this 32 thousandths, we use little baby 3/32 diameter rivets. We need 11. I don't like that. Go over here, use 1/8 rivets. They're bigger diameter, so we can use a smaller number. What if I want even less rivets? 5/32. Big old chunky boys. But look, there is the underlying number. We could use only 3 if we go with 75% rivets, but since this number is above our underline, that means it is going to tear, the sheet metal will tear in bearing because this is such a big diameter rivet for that thin thickness of material. So as you come across, you want to stop and not use this larger size and stay with the smaller size rivets. Yeah.
I'm a little confused by what it means per inch of width.
Per inch of, I think maybe in the chart, it's just saying if you see W anywhere else in the chart, it's referring to width.
Is practically speaking,
inch of whatever the
Multiple
row
rows.
of rivets that you're riveting.
Multiple rows? Just to get within that 1 inch?
Just
That's a good question.
for,
6 rivets.
so like, however long your row of rivets, whatever that width is. Every inch has to have that many rivets.
Oh, wow. So you'd make multiple rows to get
Correct.
that strength.
Exactly.
Okay.
Yep. Like that guy there. Kinda.
Oh, okay, so if you needed 6 rivets in 1 inch, you could do 3 and 3
Correct.
per inch. Isn't that what it's talking about?
Right. Like you would have to do multiple
Oh, I
rows.
see, okay.
Yep.
Thank you.
Yeah.
The numbers to the right of the underlined numbers, are those assumed to be underlined or not?
Correct.
Is those
Yes.
also-
Well, because our underline comes down here, down
Everything
there.
to the right would also essentially be underlined. They just didn't.
Like,
Yeah, so every number that's to the right of an underlined number is stronger than the underlined number, so it would also feel underbearing.
Correct.
Those should all be underlined too, they just didn't.
well, the underline is down there. So that means everything above it is too strong. And then it drops down to here, everything, they don't even give you the option there because it's way too strong. But yeah, the underline is still there.
Okay.
Is that what you were,
I understand that, I was saying all the things in the underline. Like,
No, because it says,
because it says, yeah,
above.
rivets above underlined numbers are critical and bearing.
oh, my bad. Yeah.
I get it.
Sorry, and the other thing, the thickness is total thickness of the materials we're joining together, right?
Correct.
Okay, thank you.
Yep. Yeah.
So, like 4.9 rivets, you're not rounding up, right? Are you, or?
So this, you kind of see where you're at. So if, let's say we're down here. That's a nice set. Okay, 7.7. So we have wiggle room that we could go either way. So we could, and depending on what you're doing, you might do the 75% of that or 60%. So there is wiggle room, as long as you don't go way outside. You can step down or step up, depending the space that you have to work in. Yeah. But I would say it's going to be very rare that you actually use a chart like this. 98% of the time it's going to be in the manual. I tell you, like our next slide will show you. Any questions? Just kind of be aware of this chart, and also know that you do need to, if you have to use a chart like this, make sure you read the notes to know how and what applies. So here's the good news. In AC 4313, and this is on page 4-19, so way back at the beginning of the chapter. Oh, no, 4-24. Page numbers have changed. I caught most of them. So page 4-24, still paragraph B, bravo. Replace rivets with the same size and strength. We already read that. But here, you use the same size, same strength as what you removed, same rivet spacing, and same edge distance as the original. So if you're replacing a part on your aircraft, save the part that was damaged. Use it as a template, unless it's damaged beyond, way too bad. But you can still use the old rivet placement of the old part as a template. When you develop a new part, just keep that exact same rivet spacing. Use the same type of rivets. And this is from Cessna Structural Repair Manual, and it says use existing rivet pattern and rivet size. And and it tells you 1/4 minimum edge margin. So it gives you that information. If it doesn't, then you fall back to AC 4313. But even in the manufacturer's manual, rivet layout and spacing is based on the diameter of the rivet used and the type of rivet head, because the diameter determines our strength. And what was the difference as far as strength overall between a universal and a flush head?
Flush head will be weaker because
Yes.
it's digging into the metal.
So flush head, you have to, it's going to be a little different spacing because of the damage, basically, that you're doing to the material. Here you go. Here are your initial rules for rivet spacing. And some of this is from AC 4313, some is in your textbook. I made it all nice in one place on one slide. Let's see, let's go to AC 4313 first. So on page 4-25 and also 4-24, some in the paragraph it talks about this, and some of it you have to pull out of that figure 4-5. It's kind of dispersed through both of those, not super clean. This is what it is. But from that, your minimum edge spacing, so from the edge of my material to where my rivet can, and also from the bottom edge up to where my rivet is placed, the minimum, absolute minimum you cannot go below is 2 times the diameter of the rivet. So you have the 3/32. 3/32 times 2 is your minimum edge spacing. And remember, you can't have it too far from the edge or it will start to fold out. So it can't be more than 4 times the diameter away from the edge. So what do you think would be a good diameter for edge spacing? 3. Nice and safe. Right in the middle. There's another trick I'm going to tell you later. Minimum single, and this is for protruding heads, so either universal or round head. For protruding head rivet, a minimum single row spacing. So now we have a row of rivets, and this is how far does one rivet, the center of one rivet, have to be from the center of the next rivet. All of this spacing is measured from the center of the rivet. So when you have a dot or a dimple, that makes it super easy. Minimum single row spacing is 3 times the diameter. So 3D for row spacing, 2D for edge spacing. And again, these are minimums, so you cannot go below them. Best to go a little bit above them.
How much? A little bit.
We'll talk about that. Now, if you have a countersunk head or a flush head, because you don't want the damaged metal to be too close to each other, you have to give a little more margin. So, minimum edge for countersunk, we just add a half. So, 2.5 minimum, 4.5 maximum, and single row spacing 3.5. So countersunk, just give yourself a half extra. Questions on those requirements? So, we already talked about, you can't be perfect. Hopefully that doesn't happen to you. However, a person let this be an encouragement to you. A person who never made a mistake never tried anything new. So, if you're making mistakes, good for you. You're trying new things. So, you're going to allow room for error. You're going to stay away from the absolute minimums. That's very curious. Your book, and I want you to turn in your book, in your airframe textbook, to page 4-34. There's something I want you to mark. 4-34. At the top of page 434, there are two paragraphs. I'll read them so you know what they are. So it says there are two methods for obtaining edge distance. That first paragraph says, this is my summary, that you can add 1/16 inch to minimum edge distance or minimum spacing. Just add 1/16 inch. So you're calculating your diameter, and then now you have to go and add 1/16 inch. Number one, that's annoying. Number two, it starts to break down. It works in their example. They have 2 times a 3/32 inch rivet and add 1/16 inch, and they get a 1/4 inch, which is a safe edge distance. Once you've got larger rivets or different spacing, like 3D, that breaks down, and that does not give you enough space to size up the next rivet. So, you can cross out that, because it only works for a couple scenarios. So you're not going to be adding the 1/16 inch, because once you use size 4 rivets or go to 3D spacing, it's not going to allow you to size up. The super easy method is when you do your calculations and you're determining 3D spacing or 2D spacing. When I say that, it means 3 times the diameter, 2 times diameter. Just use the next size up rivet. So if you're doing it for a size 3 rivet, you're going to drill when you finally get to drilling for a size 3. But your math and calculation and spacing, you will calculate with a size 4 diameter rivet. So instead of calculating for 3/32, size up, you calculate for 4/32. That's perfectly safe within, well within maximum for a size down. And now, if you mess up a hole, you're ready, you can size up perfectly fine. Yeah.
So, the maximum is 4 times the diameter.
For edge.
Is this for, oh, this is the maximum for distance between?
For distance between, 3D is the minimum
Yeah.
per row, but you'll find in some applications, it can be up to 10D, depending where it's at and what the
So,
purpose is.
but what we're calculating right now is the edge distance.
So this rule applies for edge distance and rivet spacing,
Oh,
all of it. So just because 2D is a minimum and 3D is absolute minimum, so you want to go always stay away from absolute minimum. Now, you don't want to just go way far away or bad things will happen, but just size up and that'll be perfect. So that allows 4 rivets to be oversized without violating the minimum. So that gets a gold star, and we won't use adding 1/6. Everybody got that marked in your book?
I got that marked. One question though.
Yeah.
Does this guy have ears before or after? Maybe he, I don't know. It looks like he's tried 2 times.
I see that. That's kind of disturbing. Poor kid. No. So, you would take, you still use that, let's say we have a 3/32 rivet we need to install. You just calculate with a 4/32,
Yep.
4/32 times 3. So you still use that, so that way, cause,
That's 3D.
yep, and then,
How about 432 rivet?
yep,
Okay.
and then you'll still drill the size hole for the 3 rivet, but if you mess it up, you can size to a 4 and you still,
If you mess it up.
yep,
Right.
which hopefully don't. But,
So, you can have 4D plus the extra size of if it was as if it was the size of rivet. Or is 4D the sharp line? And this is just.
no, you
pure
could,
wall.
like you could have a little wider spacing, but you really don't wanna start getting too much spacing, or now you're getting away from, you may not be recovering the strength you need. And this is only if you don't have the manufactured maintenance in.
Most of the time, we're gonna take what we took off,
Yes,
copy size.
just duplicate. Yep. Yep. Okay, before we talk about how to actually lay out rivet, take a break. Come back at 1:30.
Whenever I watch a, aircraft investigation, I see this aircraft crash, I'm gonna cry a little bit more, thinking of all the work.
Yes. Yes.
The labor.
rivet cheat sheet.
Oh.
They just put all of the little like, they're not like hog up formulas, just like so little
No.
cheapness, and it just sticks there. It's crazy.
You should totally like
And
print a copy of that.
Sell them
It's all
a quarter a piece.
Sell them?
But see,
Or
I mean,
you could
increment
just make
payments
your
are
own.
There you go, transfer profit.
Yeah.
So,
Alright, Caleb, that'll be $5.
I get
Yeah.
80%.
Did you want
I
that?
printed out nothing.
It's probably worth the $5.
Oh, yeah.
Is it really worth the $5 if you can't look up the formulas yourself?
No, you just need 3 for everything.
See, but
3 for the edge, and 3 for the distance.
You're saving yourself
Because that puts you
time.
within a range of all of them. You just use 3 as your number for everything, and then you size up with it. You add
Yeah,
two
I like
base.
that.
You have to filter size it.
Whoever, some master made one just like that and just hung it up at my workstation. And it's like, I've got to get one. Hung it up, my workstation was not. Oh, look, I have a typo.
I was gonna say, is everything on there accurate? Correct? Or are they messing them up?
Yeah, I'm just,
So
I'm
do it,
Caleb, you better not trust it, yeah.
Hey, the fact that you tried to.
halfway out and
Couldn't quit when you were just like, nah.
I think the heavies are, it is heavy catch. Actually, it might be more. It might be more.
I think you're right today.
I don't know, I haven't written down, I haven't written down.
I found that out now.
I haven't written down on lifting though.
Dude,
Wow.
it's just, it's just.
It's disturbing that now other people think it's cool.
That means it's like,
I
Way
have
too
to,
cold.
Yeah. Time for me to pull out the real winter gear.
What's the real winter gear?
I'll have to come up with that.
like abominable
Stuff you
snowman.
Like a fully insulated, like, astronaut suit.
The
Yup.
things and the fur thing,
Oh.
Yeah, like one of those really furry hats.
the ski goggles.
I work outside.
Do I have a hat? I don't know what I have. I have a Christmas hat, a little Santa hat.
After that.
I have a
See, well, my thing is, I don't really.
Just pull it right over your face.
I do a higher rep.
That's what I did to mine, it's like, wait,
You just, that's how you know you're a man.
It just really says MAF hat.
Back outside.
When they came for their waypoints, they had a bunch of those hats.
Oh, yeah.
I got that hat with an airplane on it.
Oh,
Oh, wow. It needs a little bit. Mine's just restrict vision so much, and then I can't hear well.
yes.
And then they spread out like that, and it's like, what's the purpose?
True. No, you need a
Typo. Like, this is a typo. 5 seconds to find the difference.
It doesn't matter.
Well, there you go.
Yeah, just one of them is wrong.
Right.
And you will fail the class. That's the difference.
Did you want one?
Sure.
Yeah, do you want one? They're awesome.
And then is the 10 minutes outside walking from a car to a building worth all that hassle to get inside and have to deal with the bulky winter gear for the day?
Right.
Oh, Dory.
Yeah, Dory.
That is the question.
What if I get stuck outside?
That's what I ask myself. Yeah, I keep a whole winter supply in the back of my car, like
Oh, there it is.
coveralls, fuzzy hat, big boots.
See, that's what I would do. But I haven't. I can fill up my tires the way they are.
I found it. Let's see how long it takes. I circled it.
Got one of those snow brushes.
So it's
There you
yeah,
go.
yeah,
Does it have a spray for that, right? Excellent.
But it's not on this one that he just handed me, but it is on that one.
No more typos.
No more typos.
Really?
No more typos.
What did you say? What did you say?
Tuesday. Says the one with 9 instruments. Case in point. Yeah. Well, you have 8 guitars. So yeah, I think I understand.
Emphasis on baby.
Like I have a buddy, dude, and he's like, yeah, man, I almost went to like, I was like, dude, you way too forty, bro. Pound for pound, he's like, dude, I wish I was double your weight. He's like, you're also double my weight. You're like, yeah, pound for pound, you're definitely not.
So if one of us is the dweeb here, it's you. I'm just a nerd. Whoa.
I didn't know there was a difference.
Name calling starts now. Oh no, buddy. This name calling started a long time ago. When we met each other, you told me you shut your mouth.
I call names all the time. I miss Christina.
It's still
Actually,
But you call appropriate and respectful.
yes, appropriate and respectful.
For you or the person you're calling.
Yes. See, it goes both ways as a we keep each other in check.
But if you take the definition of a dweeb, a really cool person with amazing music knowledge, everybody knows that definition. They're like, I want to be a dweeb.
Oh, is that what it is?
You look at me for.
I mean, it's people know me.
I don't know, I haven't heard of it.
What did I do?
There's a lot of
I
Partner.
I gathered. Alright, I'm gonna do something fun. It could be slightly chaotic, but one person talk at a time. So we've been talking about what's required for rivet diameter, or rivet length, what's required for absolute minimum spacing. So let's say I wanted to throw rivets, I wanted to put another sheet of metal on here. Any ideas, how in the world would you go about laying out the rivets? Like what methods do you think you would use? Where would you start? Yeah.
Divider.
Very good. Yes. Divider. What would you do with it?
Well, that's just anything, equal space.
Yeah.
Measure your two edges,
Oh. Oh.
and then use those to
Ooh.
evenly.
Gold star. Excellent. So, this is what Dwayne gave to my class. Actually, he talked through it. I wrote it down, and I'm so thankful I wrote it down because now I can share it with all of you so you can get Dwayne's wisdom of the best way to lay out rivets. So I would advise either write this down or take a picture. I will post these PowerPoints later, so you will have access to it. But I'm going to read down through this, and then I'm going to show you what it looks like with some very sad poor animations on the next PowerPoint. So, exactly what Randall said, when you have a piece of metal, you figure out what your edge distances are. So you have to remember you have this edge and these edges. So you determine what that is, and if I have a 3/32 rivet, I questions on that? Okay. So, determine and mark your edge distance. That's going to be based on your rivet diameter. Remember to size up, and then you can just use minimum. Then you're going to measure the distance between those two end rivets that you marked. So now you measure that. So here's where it can start to get a little hairy, and I'll show you that, do that on the next slide. But mathematically, you'll measure the width of your piece. So then from that, mathematically, you'll know what should be the distance between your rivets. Do you think you're going to get that exact number when you mark it with a little marking device? You might. You're going to. I am not allowed to inflict violence. Some of you will. Some of you will get close. Some of you won't. So try to be as accurate, precise as possible, but you're going to realize, oh, I'm a hair off, and that's why we size up to give you room. By the way, what marking device are you going to use?
Not a pencil. Pencil.
A fine point tip permanent marker.
That's
Yeah. Ultra fine tip. Sharpie, yes. Quick in the draw.
Oh,
Boom.
man. It's mine now. Paint's gone.
All right. So then, once you mark or measure the distance between your two end rivets, so now you have in-between distance, you're going to divide that distance, so it might be 5.5 inches. Divide that by required rivet spacing. So let's say I tell you, I want you to get as close to minimum as reasonable, and you have a 3/32 rivet. What spacing would be reasonable in fractions for a 3/32 rivet to rivet spacing? Saying and what's that in fractions? So 3/8. How did you get that?
I upsized the rivet and then multiplied that by 3D.
Excellent. So I gave you, I said 3/32 rivet. We're going to upsize to do the math with a 4/32 rivet. And what is minimum rivet spacing between rivets? 3D. So just take 4/32 times 3, and that will be your spacing between rivets. So you take that number, which was 0.375, and you divide the distance between your end rivets, so let's say it's 5.5, divided by 0.375, just for the fun of it. What is 5.5 divided by 0.375? 14.6666667. Can we put, so that is going to give you 14 is mathematically the number of spaces that is going to be in your piece. So if that's the number of spaces between rivets, you have to round up or add approximately 1 to that number for finally the total number of rivets needed. So we got 14.6, we can't put in 0.6 of a rivet. So round up, it'll be 15 rivets. So 15 rivets is going to give us, fill in our area with 0.375 spacing. However, our spacing was 14.6. So that, if we try to stuff 15 rivets in there, our spacing is going to be a little off. So then, And yes, dividing it by
Okay.
the spaces, which was 14 from step 3. Yes. Yeah.
Isn't it by step 4 though? Because
No. Because you are trying to figure out what is my spacing was 0.375,
yeah.
but that's not going to work with 15 rivets. It's going to be slightly different. So now you got your total number of rivets. You're going back to what the spacing should be. Yes.
So when we go back to that number, are we rounding down so
Yep.
that the spaces are bigger and not smaller?
Correct.
Can we use a rivet pen?
No, not for a while. Because you will be asked to do rivet spacing, very possibly impractical without a fan. So we don't really allow them. Maybe towards the end, once we see you doing good with this. But because you may be tested, that's why and we don't have very many. We'll talk about it, but.
You're saying fan?
So I'll show you. It's like a thing, and I'll have a picture later. You'll also read about it here. But you can spread it out, and it kind of does your rivet spacing for you. But you may not always have one. We don't have many here. It's not always super practical. So once you get this method down, you're going to have lots of experience and practice with it. It's going to get easy. I promise that. Like it will, you're going to get used to it after repetition. And as you do it, it'll make sense. It'll make logical sense. Like, oh yeah, this makes sense. This works out. And then when you are placing your rivets, so you place your first 2 on the edges. As you are laying out, make sure you go from one side, then to the other side, back to that side, back to that side. Because, and work towards the middle, your last rivet, you're probably going to be a little bit off by that point. So instead of measuring point, whatever it was, 392 from the last rivet on this side, your very last rivet, you just center it between the previous 2. It'll be a little bit off, but at least you center it between the last 2. Because you're going to get off. Yeah.
So with getting the spacing right, I would assume we would draw a line and then mark, but we can't draw a line because we're trying to leave as few markings as possible, right?
So that, I didn't grab it, that's where the masking tape is beautiful. You just lay down a piece of masking tape and you can mark on there all you want. If you mess it up, off comes the masking tape, down goes a new one, and mark it up again. But the Sharpie wipes off with alcohol. So if you preferred marking your Sharpie right on there, it does wipe off pretty easy with alcohol, which is why it's such a useful tool in sheet metal. Okay, so let me show you this. Did everybody get a picture? Write that down. Here's what it'll look like. So we've got a piece of metal. And we measured a piece of metal 4.25 inches from one end to the other. They want us to use AN 470 AD 3-4 rivets. Well, that's very lovely. So if we're going to start off marking our edge rivets, what should my edge spacing be with margin for safety by staying as close to minimum as possible, reasonable? What should it be for a size 3 rivet?
0.375.
Give it to me in decimal. Say again, I didn't hear.
0.375.
For edge spacing.
0.187.
All right, tell me your process. 3/32 rivet,
Right, so you use 4/32.
but we size up. So what's the next size up from a 3/32?
4/32.
4/32. And now we take 4/32 times what is minimum edge spacing?
3.
Edge spacing is 2.
2, right.
So 4/32 times 2 is what? You get 1/4, or 0.25. And remember that that's weird. That's really weird. It looks like a nice piece of sheet metal on that screen, but it disappeared from this screen. Anyway, that's a piece of sheet metal. I have never seen that happen. Let me just, okay. Anyway, so make sure you're going from this edge and from that edge. Because I've seen people measure beautifully up from this edge, but they're right at this edge of the other edge of the sheet metal. So you're going in and in, 0.25, and throwing down your first 2 rivets. Alright, that step's complete. Anyone remember what the next step is? Measure the distance between those 2 rivets. So, if our piece of sheet metal is 4.25, and this one is in 0.25, this one's in 0.25, what should? 3.75 should be our distance. So, when you lay out your rivets, measure that. If you're off, just erase it and replace that rivet so that you get them placed. Because this markings are for where you're going to be drilling. And when you drill, it's super easy when you center punch to be a hair off. So everything you do can get a hair off, so being as accurate with every single thing as possible will be best. So after you mark it, measure it to make sure it's as close as you can get to being the measurement that you want. So we got 3.75 between these guys. And what is our reasonable minimum spacing for a size 3 rivet? Somebody other than those that have been. And how did you do that? And what is practically considered best practice to give us margin for error? Size up. So instead of a 3/32, use a what? 4/32. And what is minimum space between rivets? 3D, 3 times the diameter. So 4/32 times 3 equals what? 0.375. Now, what are we going to do with that number? Yes.
Divide the remaining distance by that answer to figure out how many rivets one bottom.
Yes. So this one is actually really easy. So we're going to take our distance here, which was what? Anybody remember?
3.75.
So 3.75 divided by 0.375. And how many spaces does that give us? 10. That's the number of spaces. So what do we have to do to that number to get the number of rivets? Add about 1 or round up. So there should be 11 rivets total. Now, we could do that last step, which is what? because it's the same. So sometimes you'll get the number that's the same if it ends up with 10. Most of the time not.
Why is there only, why was there 11 rivets?
So it's 10, the number 10 is the number of spaces. So that is space, 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 so you get space. So you have to add one to that to get your actual number of rivets. Yeah,
So would it be 10 holes or 11?
10 spaces, 11 rivets.
So that includes the edge ones.
Correct.
Okay.
Yes. So then we lay out our rivets, starting on one side, and this you can measure 0.375, mark it. Measure 0.375, mark it. What do you think you could measure that with? Caliper. Yep. Or you can set a divider to that. And you keep going back and forth, back and forth, back and forth. By this point, you're probably a hair off. So this is where I said, for your very last rivet, just measure that space and center the last rivet. Now, if you've been dead on, it'll still be 3.375 from here and from there. Most likely not. I can't get it. I'm not. If I do it for a week, at the end of the week, I can get it. But by the end of this class, you'll be nailing it. But at first, you'll probably be a little bit off. So just, last guy, just stop and center him in between. So this is where, when I was talking about spaces, that got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces, and that's why you have to add 1 to that number to get actually 11 rivets. Bless you. Questions? Okay. Here are some words of wisdom. Don't mark directly on the aluminum. Now, I did say you can with a Sharpie, wipe it off with alcohol, but you're going to find it's best just lay down masking tape, mark on there with fine tip Sharpie, because you want to be careful if you slip off, you're still using Sharpie. Machinist scale and caliper, whichever one of those you find you're more accurate with. Be as accurate as possible. Make sure your errors are manageable. So double check every step to make sure, oh yeah, I'm within my margin. And understand your limitations. So if you find that you are super accurate with the drill, that's great. Make sure your markings are accurate so you can get accurate with the drill. And yeah, always do the math with a size up rivet too. You can have small errors and still be within minimum. Questions? Okay. So tomorrow or maybe the next day we'll kind of see how things are progressing. I will demo this again. We'll go over the steps again to reinforce it for you. But I am going to hand out your big, scary, but it's not scary, lab. So this lab has steps for a whole project. There you go. It has steps for this whole project. You're not going to finish this. I do not expect you to finish this. If you finish this before I say you should finish this, I'm going to have to scramble to look for things for you to do. This should not be finished until after Christmas. So you're not going to start an actual project today. You're going to start practice pieces. Maybe by Friday you can start, maybe. Next week you'll be working on this, and then after Christmas for a week you'll be working on this. After the week after Christmas you'll be working on this. So just know that. You're going to pace yourself. You're going to have time. We're going to have lots of lab time, especially after Christmas, where you can work on this. So I wanted to say that so that when I hand this lab out to you, we're only gonna look at the first 3 pages. I don't even want you to look at you can. But remember, this is weeks long, so don't get overwhelmed. But you do need the information on the first 3 pages. So, and it is very important that you do not lose this lab. So that's a challenge to you over Christmas. Do not lose this lab. We can print more off, but there are sign-offs that you will receive on this lab. So if you lose this, you may have to redo portions to get the sign-off. So don't lose it. But you're all responsible adults, so this won't happen. Alright, so here's what I recommend. If you are fearing that you might lose it, get in the habit of, so this has directions and instructions for what you're doing in the lab, so you'll have it with you in the lab. Right now, I want every single person to put your name on it.
Oh, damn. My head is good.
What?
I thought you were going to say, give it to Christina.
Put your name on it.
Find the nearest spelling.
Do not be taking other people's labs. That's not funny. That's not a joke. Do not do that. If you do that, the wrath of Christina will come upon you.
Uh-oh. Oh, Christ. Christina.
So don't be doing funny jokes and trying to hide somebody else's lab. All right. So now your name is on it and secure. Here's what I recommend. Since you'll have it in the lab with you, but I recommend you just keep it either wherever you feel it's most secure, in your toolbox or in your mailbox. We have a mailbox for every single person here. So it can just live there rather than stuffing it into your backpack, and then your backpack goes home, and then your little puppy goes, just keep it here, keep it safe, then, yeah. Okay, so, on the front, it says use of proper reference materials. That is going to be somewhat AC 4313, but also this lab packet. We're going to talk later about specifications, but when I talk about those specifications, make sure you follow those. Because work performed according to specifications, when we tell you in the lab a specific spacing or specific edge distance or number of rows, that's those specifications. Proper selection and use of tools. We'll talk tomorrow about riveting, rivet guns, how to care for those. So we'll be watching that you are using tools properly. Quality of workmanship. I'm looking for improvement. If you start out and it's rough, that's okay. That happens. But looking for improvement, looking for learning, looking for building a skill. Clean up. Again, that's important. Sheet metal class is lots of shavings. Keep your place clean. Don't be tracking them into the classroom, into the lunchroom. Clean off your shoes. And then safe operating practices. We had the whole PowerPoint on drilling safety. Very, very important. Where it says grade, if you want to, I don't know, highlight it or start, this packet must be turned in to receive a grade. You're going to do a sketch on here. You're going to get sign-offs on here. So that's why it's very important you keep track of it. Must be turned in to receive the grade. Here's a little note, not on this lab, but lab 1, a bunch of you got signed off yesterday. It's great. We'll get some more today. make sure you do submit lab 1 after I sign you off. So I'm taking each person to my sign-off sheet. I'm telling you I signed you off. Once that's done, just make sure you submit that so I can give you a grade, and then you don't have to worry about that lab 1 anymore. Okay. So on page 2. Page 2, yes. It says material prep practice pieces. The objective of this exercise is to develop your skills using only hand tools to cut and dimension sheet metal pieces. Now, it's just for these initial, it's going to be 3 practice pieces, but you may be asked to do this on the practical, so we need to see that you can do it. So you are going to be using shears to cut your metal down to close to dimension, hand shears. Anyone remember what the difference between these 3 are? Yes.
Left and right.
What's this one?
Center.
Straight.
Yes.
And what's this one? What's your position lights?
Red is right, red is left.
Say your position lights. Red is left. Oh, that was kind of rough. Therefore, green is right.
That was
Woo.
correct.
Woo. So, some of you have your own. We have some for those that don't have your own. How many of you have your own? Do y'all mostly? Okay. So this is something, if you go end up in a sheet metal shop, you will possibly eventually want to invest in good ones. Not now, because you're not using them very extensively. Here's a tidbit, free tidbit, if you ever do want to get expensive ones. Hold it up to the light, and you should not see light between the cutting tips. These are actually pretty good. I just see a little bit of light. A lot of these, you're going to see massive amounts of light, because they're cheap. They've been mold, had a hard life. But if you want to get expensive ones, and because you're doing a lot of hand sheet metal work, you're going to get way better cutting if you hold them up and don't see the light. Just free tidbit. Yeah.
So right hands are for cutting right turns?
Yep. Yep. And if you haven't really used them before, just grab scrap metal and just see how they cut. Just play with them. You can, I'm going to use this for something else, but you can make very gradual angles with the straight ones. It's a little difficult. These just make more of an angle. But for this, the goal is you're going to take used stock, so nobody should be grabbing out the brand new big piece of sheet metal yet. Not at all today. Maybe tomorrow, but I will clearly let you know. So no new metal, just grab scrap metal. And you are going to make 3 pieces using only hand tools. Now, if you have a large, like even this, a larger piece, because you're going to be cutting it to 3 by 6. So you can use the foot shears to get it down to 4 by 7. And then from there, use a hand tools to get it 3 by 6. So if you want to just jot down on your lab, you may use foot shears to cut it to the 4 by 7. So that's a reasonable working piece, because I don't want you to take the big piece of skin off the wing and be trying to cut that with a hand shears. We're not making you do that. So you can use foot shears to get it down 4 by 7, and then from there, cut it with your hand shears. A tidbit, make sure you're just doing small, thin strips at a time. If you try to chonk off a big piece, it's going to really warp and distort, and you're going to have a hard time getting through that. So just thin strips with these, don't cut all the way to the tip. Like, actually, I'll just go ahead and, I want to save, there, okay. As you go through, stop about a little bit back from the tip of the jaws, because if you go the whole way to the tip, it leaves a notch. It kind of goes sideways, and now it's starting to really mess up your metal. So do not cut the whole way to the tip. Just do, whoops, now it's really distorting. A little bit from the end stop, and then you can shove it forward and keep going. Then it gives you your tolerance. So it needs to be an exact 3 by 6. Your tolerance is plus or minus 10 thousandths. How do you think you'll measure that? Caliper. So you just take that, measure, make sure you're measuring the ends, measure the middle, measure all the ways, and it must be square and straight. So it can't be going off to Florida, even though that's a much nicer, warmer place. So you'll take your, hopefully everyone has one of these. If not, we've got quite a few in the tool room. So take a combination square, and you just set it on there. This is how I would check yours. And you're making sure this is actually pretty square. That's very interesting. That it is square on all edges. Then it says all corners will have a radius not less than 1/16 and not more than 1/8. What do you think is something you could use to kind of as a gauge for the size of radius? What do you say? Something even simpler than that. You already have, everyone has at their station. It won't be quite, ooh, you're getting on. What? A drill bit. Drill bit. So, for a 1/16 radius, what drill bit would I use? I think I heard a 1/8. Because that's the diameter of the drill, so you want, that would give you the 1/16 radius. So I will have a 1/8 drill and a 1/4 drill that I will hold up to the corners of your sheet metal and make sure it's between that. Here's a tidbit, the way to get a nice radius. So after you get pretty close to dimension with your shear, you don't want to go the whole way down, then you'll file it to the dimension, and then I'm going to be checking. When I grab your piece of metal, I want it nice and smooth. I don't want any owies. So after you file it to the dimension, you'll take, this is 120, that's pretty good. Just a quick little across it, make sure you get all your file marks out. And then this is 800, whatever, and just smooth that off so it's real nice and smooth and no owies, no file marks, smooth, and that's just on the edge. You're not going onto the surface of the metal. Don't remove that alclad, but just every edge. Yeah.
This is not for listening. What's the radius? Like,
Yes.
all the corners are going to be rounded off, is what you want?
Correct.
Of all 3 pieces.
Yes, and I'm going to show that to you because that's a very good question. So you want it to be between, it says 1/16 and 1/8 radius. So that, and this is, I don't know, I find this super satisfying. But you have a sharp, alley, pointy corner, so you just take a file and just knock that corner off. Bam, 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 bam. And you're kind of, you see I'm kind of taking the file like that. You could, if you want a larger radius, you could nibble off just a little bit, but you could easily get too big of a radius. So file, super easy, super quick. Just knock that down. And remember, you can go both ways for aluminum. And just boom, boom, boom. Yep, got my finger. And then, once you kind of get the corner knocked off, sandpaper, knock it down. Ooh, that's getting really nice. And I want a nice smooth radius, no corners in it. And then my finer sandpaper. And now, I have a lovely radius. And I hold up my drill bit. And it comes around the drill bit. It's not smaller than that one. And other one, it's not bigger than that one. If you can't see, that's okay. I'll have this in the sheet metal shop so you can come up close, personal to it, and see what I'm looking for when you get to that point. I kind of talked about shear marks, ragged edges, must be filed smooth. That's file sandpaper, keep it all smooth. Talked about straightness and squareness. And then here's the important part. Those 3 pieces of used sheet metal, I need to take the measurements of all of those 3 pieces, and then I will give you a sign off. The next part, part 2, material prep, we're going to skip over that. Talk about that maybe tomorrow. So, ignore that for now. Go to page 3. For a riveting project, it says, first, use a practice aluminum pieces, so those 3 scrap pieces you got signed off, and attach 2 pieces. Now it says 20 thousandths. It's whatever scrap you find. So if you can find 25 or 32, that's good. Using the maximum number of AN 470 AD3. So you're using a 3/32 rivet. So what size are you actually going to do the math with? 4/32. So you're not going to rivet yet. You're not going to drill yet. But if you get all your pieces signed off, you may lay down your tape and start to lay out your rivet pattern with that requirement using a 3/32 rivet. And it says maximum number practically allowed for a single row. And I think later you do have to use minimum edge space, so you'll use 2D for edge, 3D for rivet spacing, but using a size up rivet. Yeah.
Why would it be 3D for the in-between if 2D is the minimum?
2D edge, 3D minimum between rivets.
3D to 14.
But it's,
And that is in AC 4313 and your deck. Questions on that? Okay, what I'm looking for in the lab today, we do have you got a nice stack of sheet metal from the wings already. It's not enough for everybody. So, if you have riveted before, you're fairly confident with layout, if you've done this before, I would appreciate if you keep working on the wing, because we're actually going to prioritize the wing that has that large piece of skin on it on the far side to get that skin off. So if we can initially, first priority, get signed off on lab 1. So if you haven't signed off lab 1, work on that. Don't worry about anything else, because today is for lab 1 also. So keep working on lab 1 if you haven't got that signed off. If you have gotten that signed off, start working on the wing that has the skin to get that skin off, so we have it for this portion of the lab. If that wing fills up, then I'll start letting people grab the scrap metal and get their 3 pieces into shape. And then if you get those 3 pieces signed off, my socks would get shocked off if anybody would actually start laying out today. I don't expect that. Questions on expectations? Okay, the rest of the time is about time. And you can take a break first if you'd like.
not quick to be as quick. Question. So this is the layout that you gave us.
Oh, yeah.
For how it's laid out. When we divide the distance between the elements by the single row spacing, the first example was we divide 5.5 and then 3 dash derivative b, we're using 4 dash 3, so 3.375, and then that gets 14.67
Yep.
inches.
Or that 14.67, that's the number of spaces.
Right, so right, my bad. 14.67 spaces.
Yep.
At that point, how do you decide if you round up or down from 14.67? Because you rounded
Yeah.
down, in my mind you round up.
So for the number of rivets, you'll round up. So you'll use 15 rivets.
14 spaces.
Correct.
Okay, so if it's at all in between, you would use you would round up the number of rivets,
Yep.
round down the number of spaces.
Correct.
So for 10, it was easy because
Yeah.
you just rounded up to 11. For number of rivets, 10 for number of spaces. Okay.
Correct.
But if it was 10 point, it was like 9.9.
Yeah.
We'd use 9 spaces, 10 rivets.
Correct.
Gotcha.
Yeah.
Thank you so much. That's
You're
very
welcome.
helpful.
You just use the task instead of the other.
I don't believe
Yeah,
that you
yep. It's exactly the same. I don't have, I don't use an app.
Here's something that's